In a locked room 50 feet underground, an AI pilot just fired a simulated missile and erased its human opponent before a heartbeat even finished. No cheering, no breathing, no second thought. Just pure, unadulterated code moving faster than any human thought could ever hope to keep up with. That single millisecond has absolutely rewritten the rulebook for every Air Force on Earth, and today we're unpacking exactly how it happened, what it really means for those Top Gun pilots you watch in the movies, and why your government is already shopping for more of these ghost pilots. It's a game changer, plain and simple. Picture this, an F-16 pulling 9 Gs, a human straining every fiber just to stay conscious, and a blip on the HUD that is not a drone, not a cruise missile, but an algorithm. An algorithm that learned to fight by playing 500 million dogfights against itself. The human squeezes the trigger, too slow. The AI has already solved the kill chain, released its weapon, and moved on. The engagement lasted 0.3 seconds. That is not science fiction, folks. It is the declassified result of DARPA's latest alpha dogfight trial run last month. If that stat doesn't send a chill down your spine, then please rewind and listen again, because the same system is now cleared for live flight testing on real hardware. Think about that for a second. The problem for 70 years, air-to-air combat has been the poster child for human excellence. Lightning-fast reflexes, sheer guts, and that totally intangible feel for the fight. Yet, those same humans black out at 9 Gs, desperately need sleep, and take years, sometimes decades, to truly master their craft. Meanwhile, China's Chengdu J-20s and Russia's Su-57s are already fielding loyal wingman drones that can turn 15 Gs without even blinking. The Pentagon quickly realized that if tomorrow's war starts with a swarm of cheap, autonomous jets, sending a human inside a $100 million cockpit is like bringing a knight to a drone fight. A brave knight, sure, but utterly outmatched. The race was on to build a pilot that never tires, never scares, and frankly, never misses a beat. The solution entered the ACE program, Air Combat Evolution. DARPA paired deep reinforcement learning with a rule-based safety wrapper nicknamed Viper. Think of Viper as the older sibling who wisely grabs the car keys when the teenager gets a little too reckless. Over 18 intense months, the AI sparred inside a physics-true simulator against top USAF weapons school instructors. Early bouts were, to be honest, laughable. The algorithm often crashed straight into the ground chasing a kill, but every defeat fed a reward loop, a relentless cycle of learning that hammered home the consequences of failure. After the billionth iteration, the AI discovered something genuinely unnerving. It could sacrifice altitude for a snapshot, then recover using a dive angle human manuals explicitly forbid. When instructors tried the same maneuver, they augured straight into the ground. The AI had found air combat moves no human biology can possibly survive, movements that redefine the very limits of aerospace performance. The moment fast forward to the finals. Call sign Banshee, a veteran F-16 pilot with 3,000 hours and 3 combat tours under his belt, straps into the simulator cab. Across the fiber optic link waits a server rack humming with GPUs ready for battle. Banshee fights like a textbook, stacking energy, keeping his corners tight, executing every maneuver flawlessly. The AI, however, doesn't care about elegance. It cares about probability contours and optimal outcomes. At a merge speed of 1/200 knots closure, the AI nudges the stick 0.7 millimeters. Yes, that is the recorded input, drops flares, and snapshots an AIM-9X from an off-bore sight angle engineers call impossible. Banshee's pupils are still dilating when the kill symbol flashes across his screen. Total fight time 0.3 seconds. 10 more rounds follow. The AI wins every single one. Researchers call it superhuman latency, but pilots, they're calling it unemployment. Why milliseconds matter? A human neuron takes a glacial 13 milliseconds to fire just once. The ACE AI, on the other hand, completes the entire observe, orient, decide, act loop in a blistering 3.2 milliseconds. That means by the time a human pilot even notices the bandit, the AI has already run 20 iterations of every possible counter move, weighed the probabilities, and initiated its response. In the real sky, that tiny delta is the difference between launching your missile and never even knowing you were targeted. Air planners translate that into an incredible force multiplier. One autonomous wingman could potentially equal 10 manned fighters in raw kill count. Budget hawks absolutely love the math. Pilots, though, are left wondering where the honor went in a fight like that. The ethical abyss here is where the story pivots from awesome to profoundly unsettling. The simulation ended with a kill button, a clear human override. But next year the Air Force wants to bolt that exact AI into the X-62A Vista, a real F-16 that can fly itself. Rules of engagement will still require a human on the loop, but here's the catch. That loop is measured in milliseconds. If the algorithm launches against a pilot who turns out to be civilian, who stands trial? Is it the programmer, the commander, or the contractor who built the GPU? International law currently has no category for algorithmic intent, leaving us with an accountability black hole that swallows any clear line of responsibility. Meanwhile, Russia and China flat out refuse to endorse any UN ban on fully autonomous weapons. We're staring at an accountability black hole wearing aviator shades, and it's a terrifying sight. Mid-roll CTI. If this is your first time hearing about sub-second dogfights, then you need to hit that subscribe button. The next video breaks down how swarming drones will escort cargo planes. And please like the video so the algorithm, yes that one, shows it to more people who really need to know about this. Human AI teaming. The sales pitch Air Force brass insists the future is all about manned-unmanned teaming. Picture loyal wingmen drones flying ahead of an F-35, soaking up missiles and returning crucial data. The human remains the flight lead. The AI becomes the expendable wingman, a silent partner in the fight. Viper is billed as the ultimate guardian angel. If the human blacks out, Viper lands the jet. If the AI wingman goes rogue, VIPR yanks authority back. But skeptics note that every single safety layer adds latency. In a millisecond fight, that handoff itself can be lethal, a fatal delay. Pilots joke, a little grimly, that the AI is loyal right up until the microsecond it calculates a better survival path by ignoring you entirely. Arms race math. DARPA's budget for ACE was $150 million, replacing one trained pilot who cost $10 million to mint. The program literally breaks even after just 15 saved lives. Congress sees an undeniable bargain here. The catch, though, is a big one. Adversaries can easily copycat the open-source reinforcement learning code and strap it onto a $2 million drone. We risk creating an ecosystem where autonomous air war becomes the default, because everyone can afford to play. Historians have a term for that kind of dynamic. Stability instability. Big wars might stay cold, but small skies? They'll burn hot all the time. Section 8. Collateral. In the blink of an eye, speed itself becomes a hazard, a terrifying double-edged sword. An AI that decides in 3 milliseconds will outrun any lawyer's review, any human ethical deliberation. In a crowded border zone, misclassification, a simple mistake, can down an airliner faster than a human supervisor can even shout, "Hold, fire." The Air Force counters with better training, data, millions of civilian radar, cross-sections meticulously labeled, but outliers always slip through. One errant missile, one tragic error, turns diplomatic calculus upside down faster than any apology press conference could ever hope to fix. Regulation. Upstream versus downstream. European states want upstream regulation. Ban lethal autonomy now. Debate the nuances later. The U.S. argues for downstream rules, letting the tech evolve, then patching law around it as needed. Between those two opposing poles, industry grinds ahead relentlessly. The same firms building AI dogfighters are also training your Netflix recommendation engine. Dual use is absolutely baked in. Absent a global treaty, the only deterrent becomes mutual assured autonomy. If we all fear the millisecond missile, perhaps nobody pulls the trigger first. Maybe. The moral counter-argument. Some ethicists claim autonomous weapons are actually the moral choice because they remove human fear, potentially reduce collateral damage, and never, ever commit atrocities like rape or pillage. An AI wingman devoid of self-preservation instinct can accept certain death to save a village. A terrified human teenager might not be able to. Framed that way, refusing to field this tech potentially costs lives. The calculus is brutally simple. Build the ghost pilot and risk unforeseen accidents, or stick with flesh and blood, guaranteeing higher body counts tomorrow. There is no clean answer here, only a sliding scale of blood and difficult choices that challenge our very humanity. Conclusion. So, an AI just won a dogfight in milliseconds, and every general on Earth took notes. The simulation is over, but the countdown has undeniably started. Within 5 years, the first fully autonomous air combat wing will deploy, operated by someone who never breaks a sweat, never feels fear, The terrifying question is no longer whether the tech works, it absolutely does, but whether humanity can survive the sheer speed at which it decides to kill. As you finish this video, somewhere underground, the next iteration is training, racking up billion-round simulations before you can even blink. Ask yourself, do we trust the code more than the conscience behind the visor? Drop your answer in the comments, share this with someone who still thinks dogfights are just Top Gun nostalgia, and I'll see you in the next one, if the millisecond lets us.